Don't forget to subscribe and press the bell icon to never miss a video from testbook.com.
Hello, good morning everyone. Good morning students. So students, today what we are going to do is that after discussing the principal stress and strain and after solving the numericals on the principal stress and strain, we have come to this particular topic which is called as the SFD and BMD, or the shear force diagram and the bending moment diagram. Clear? Again, you must have read about the shear force diagram and the bending moment diagram in your semesters also, and you must be knowing that it is a very important topic, but sometimes it becomes very difficult to draw the SFD and BMD of a lot of structures. It might be overhanging structure, it might be a structure with a UVL, uniformly varying load, right? It might be a structure with a UDL, uniformly distributed load, and so on. So that is what we are going to discuss, that how to draw the shear force diagram and the bending moment diagram for various type of load combinations and for the various types of support conditions. Clear? But first of all, you should know that why is it important to draw the SFD and BMD? Why do I need to draw the SFD and BMD? Clear? So students, there are n number of, you can say, uses for the SFD and BMD. As from the name, it is clear that SFD stands for shear force diagram. It basically tells you the distribution of the shear force at various sections on a particular beam, if it is a beam. Clear? And if it is a column, then column. Similarly, BMD stands for bending moment diagram. So it is a diagram which tells you the distribution of the bending moment at various sections of a particular structure. It might be a beam, it might be a column, it might be anything. Clear? The question is, sir, okay, even if I know the distribution of a shear force and even if I know the distribution of bending moment, what is the use for that? So students, after this particular chapter, we have another chapter which is called as the shear and bending stresses. Ultimately, due to these shear forces and these bending moments, what is going to happen is that various types of stresses are getting generated in a particular member or in a particular structure. And those stresses should not go beyond the allowable limits. Because if those stresses go beyond the allowable limits, we might have the failure. And the failure might be of two types. I have told you that in the previous lecture also. It might be due to deflection, it might be due to the rupture also. Clear? So the failure should not happen in a particular beam. If it is a beam, it might be a column also. Clear? So we calculate or we draw the shear force diagram and the bending moment diagram just to know the various shear stresses and bending stresses at various locations. And the location at which we have the highest bending stress or the highest shear stress, that is said to be as a critical section. Clear? And we need to design the structure in such a way that the stresses at the critical section are below the allowable stresses, because if they are above the allowable stresses, the structure is going to fail. Clear? So that is the overall motive of understanding this topic, which is called as the shear force diagram and the bending moment diagram. Before proceeding further, let me tell you a very important thing, students. You can go for the textbook pass. So we have one pass for more than 100 plus courses. You will be getting an access to more than 6,500 plus mock tests. A lot of selections we have already made in different competitive exams. You will also be getting a good exam strategy as well as the expert guidance. And the textbook pass is only for ₹499. So it is a once in a lifetime pass sale which is going on right now. The textbook pass will be valid for next 3 years. ऑल्सो स्टूडेंट्स, अगर आप में से किसी को जो है गेट सिविल इंजीनियरिंग 2022 की प्रिपरेशन करनी है तो आप जो है टेक्स्ट बुक की साइट पे जाकर के अपने लिए कोर्स ले सकते हो. इट इज अ पेड कोर्स बाय द वे, बट आई कैन हेल्प यू इन वन वे. जो आपके स्क्रीन पे जो कूपन कोड नजर आ रहा है आपको, दैट इज वरुण एंड अ कैपिटल ऑफ के. आप इसको एंटर करके आप अपने लिए 20% का डिस्काउंट अवेल कर सकते हैं. Also students, since it is a free series which is going on YouTube, the only motivation that we have got from your side is that you like, share and subscribe to the channel. Also you press the bell icon so that you can get the notification of all the newly added videos. चलिए students, आगे बढ़ते हैं. Now, first of all, let us do some introduction on the SFD and BMD. A little bit of introduction on the SFD and BMD. That why do we use the SFD? Why do we use the BMD? And what is the practical use, right? So students, I have just told you that to calculate the shear and bending stresses at various locations. To calculate the shear and bending stress at various locations, we go with the SFD and the bending moment diagram, shear force diagram and the bending moment diagram. Okay, just wait a second, students. Wait a second. Okay, students, so let us proceed further. So why do we draw the SFD and BMD? SFD and BMD are drawn just because to get the shear stress distribution and bending stress distribution. Clear? So that you can get the allowable bending stresses and the allowable shear stresses. Let us proceed further. So students, first of all, the concept of the shear force. Now, what is the concept of shear force, students? See, understand very carefully. If you have equal and opposite forces acting at a particular distance, you can say separated by a distance, you will find that some couple is being generated, right? Some couple is being generated. So students, what is this shear force? The concept of shear force is that a shear force is a force applied perpendicular to the surface in opposite to an offset force acting in the opposite direction. This results in shear strain. In simple terms, one part of the surface is pushed in one direction while the other part of the surface is pushed in the opposite direction. This is the difference to compression which occurs when both the forces are pushing into each other at the same point. Okay, I hope that you have got it. For example, this is a body. On this particular body, you have some force acting in this direction, you have some force acting in this direction. So at this particular junction, you will find that there is a shear effect, and that shear effect is basically caused by the shear force. Clear? So shear is very simple, as simple as that. For example, this is a surface. On this particular surface, some body is resting and you are applying some force from this particular direction. So you will find that this body will become somewhat like this. Clear? So there will be a shear deformation on this particular body, and some shear strain will also get developed. How to get the shear strain, I have already told you in the previous lectures. So that is what the shear force is all about. It is different from the compression force. In compression force, what do you have is that, for example, this is a rigid surface. On this particular rigid surface, you have a body and you apply some force here, and here we have the compressive forces acting, or the compressive stresses acting. So this is what the compressive stresses are. It is totally different as compared to the shear forces or the shear stresses. So very simple concept of it, right? Let us proceed further. Let us understand the bending moment now, right? So students, in the previous lectures also, when I told you about the engineering mechanics portion, I told you what is this bending moment. Clear? So whenever a force is acting at a point separated by a distance, that particular force creates a bending effect at that particular point, and that particular, you can say, force is called as the bending moment. So bending moment is also a type of force. It is basically an effect caused by a particular force. Clear? And bending moment is equal to force into perpendicular distance mathematically, and graphically it basically represents the area of triangle. Go to the previous lectures, you will find it. Now what is this area of a triangle? Clear? So bending moment is the measure of the bending effect which can occur. I have written it here also. So it is a measure of the bending effect that can occur when an external force is applied to a structure element. This concept is important in structural engineering as it can be used to calculate where and how much bending may occur when forces are applied. So it basically tells you about the bending effect. Bending effect. Clear? Also students, the sagging moment is generally taken as positive. In the previous lectures also, when I taught you about the sign convention, there also I have told you that the sagging moment is taken as positive, hogging moment is taken as negative. Now what is the meaning of the sagging moment? Again I am explaining you. For example, this is a structure. On this particular structure you have a moment here M, clear, and similarly you have a moment here that is also M. So you will find that this particular structure will get D-shaped in this form, and this is a sag form. This is a sag form. Clear? So this bending moment and this bending moment, they are said to be as the positive bending moment. These are said to be as the positive bending moment. Similarly, if you have a structure like this, and on this particular structure, students, you have a moment which is acting in this direction, you have a moment which is acting in this direction. Clear? So this structure will become somewhat like this. Okay, this will get deformed like this, and this bending moment is said to be as the hogging bending moment, and it is generally taken as negative. Hogging bending moment is generally taken as negative. All these things we have already discussed in the previous classes. If you have not hello sir ji, live ho? Yes ji live hai. अमरपाल जी कैसे हैं आप? ठीक है. So this is what is called as the hogging bending moment. All these concepts we have already discussed in the previous lectures. If you have not watched the previous lectures, I would recommend that you go and watch the previous lectures. Clear? तो ये तो हो गया मेरा सैगिंग मोमेंट का, हॉगिंग मोमेंट का, और ये हो गया मेरा शेयर फोर्स क्या है, बेंडिंग मोमेंट क्या है. ऑलरेडी पहले भी बता चुका हूं मैं आपको, लेकिन मैंने इसको दोबारा आपके लिए रिपीट कर दिया है. चलिए स्टूडेंट्स आगे बढ़ते हैं. नाउ अब जरा चलते हैं टाइप्स ऑफ स्ट्रक्चर्स के ऊपर. कि देखो, अगर आपको ये नहीं पता, इफ यू डू नॉट नो व्हाट आर द वेरियस टाइप्स ऑफ स्ट्रक्चर्स वी हैव, इट बिकम्स वेरी डिफिकल्ट टू ड्रॉ द shear force diagram and the bending moment diagram. So at least you should know what are the various types of structures, what are the various types of supports we have, and what are the various types of loadings we can have on a particular structure. That is very important to draw the SFD and BMD. After this, you will take hardly 10 seconds to draw SFD or BMD of any structure. Clear? I'm not joking about it, but yes, you will take hardly 10 to 15 seconds to draw the SFD and BMD of any structure. But for the time being, you should know what are the various end conditions, support conditions, loading conditions we have to draw the SFD and the BMD. Okay. So students, the first type of structure is called as a rigid framed structure. Now students, what is this rigid framed structure? As from the name it is clear, the joints are rigid joints. Rigid joints बोले तो कि joints पे आपने welding कर दिया. क्लियर? जॉइंट्स पे आपने वेल्डिंग कर दिया तो उनको बोला जाएगा रिजिड जॉइंट्स. रिजिड जॉइंट की बहुत सारी प्रॉपर्टीज है स्टूडेंट्स. क्या प्रॉपर्टीज है सुनिए बड़े ध्यान से. नाउ रिजिड जॉइंट्स, स्टूडेंट रिजिड जॉइंट्स की क्या प्रॉपर्टी है कि वो जो एंगल है वो कभी भी चेंज नहीं होता. फॉर एग्जांपल लेट अस से ये आपका एक जॉइंट है, ये जॉइंट के बीच में जो एंगल है ये 90 डिग्री है स्टूडेंट्स. आपका आपने यहां से फोर्स लगाई, आपने यहां से फोर्स लगाई, आपने मूवमेंट लगाया, आपने कुछ भी लगाया, ये स्ट्रक्चर आपका डिफ्लेक्ट होगा. द स्ट्रक्चर विल गेट डिफ्लेक्टेड बट द एंगल विल ऑलवेज बी 90 डिग्री. द एंगल इज नॉट गोइंग टू चेंज एट ऑल. दैट इज द प्रॉपर्टी ऑफ द रिजिड जॉइंट. तो अगर ये स्ट्रक्चर थोड़ा बहुत टेढ़ा भी हो जाता है तो ये जो आपका एंगल है ये आपका हमेशा 90 डिग्री पे बना रहेगा. क्वेश्चन ये है कि सर 90 डिग्री पे क्यों बना रहेगा? व्हाट इज द रीजन फॉर दैट इट इज गोइंग टू बी 90 डिग्री? द रीजन इज स्टूडेंट्स बिकॉज यहां पे आपका रिजिड जॉइंट में क्या होता है, जितना मोमेंट आपका यहां पे लगेगा, आपका लेटर से दिस इज इक्वल टू मोमेंट m, सेम मोमेंट आपका इक्वल एंड ऑपोजिट डायरेक्शन में यहां पे भी आपका m मोमेंट लगेगा. एंड दिस इज द प्रॉपर्टी ऑफ द रिजिड जॉइंट. क्लियर? ध्यान रखिएगा स्टूडेंट, बहुत इंपॉर्टेंट है रिजिड जॉइंट की प्रॉपर्टी आपकी. तो ये तो आपका हो गया रिजिड जॉइंट. रिजिड जॉइंट जैसे कि आपने वेल्ड वगैरह लगा दिया इसमें, दिस इज व्हाट द रिजिड जॉइंट इज ऑल अबाउट. सो वेल्डेड जॉइंट्स को भी आप लोग जो है रिजिड जॉइंट्स की कैटेगरी में आपस में रख देते हैं. ठीक है, चलिए आगे बढ़ते हैं स्टूडेंट. इसके बाद है आपके पास ट्रस जॉइंट, जिसको बोला जाता है कि पिन जॉइंटेड स्ट्रक्चर्स. राइट? सो ट्रस जॉइंट और विच इज आल्सो कॉल्ड एज द पिन कनेक्टेड स्ट्रक्चर. देखो पिन का मतलब क्या? पिन का मतलब है एक हिंज. राइट? ये हिंज क्या होता है देखिए स्टूडेंट जरा. ट्रस. So this is what the truss is. क्लियर? सो दिस इज व्हाट द ट्रस इज. ये ट्रस में क्या होगा स्टूडेंट्स, ये जो आपके जॉइंट्स है ना, ये जॉइंट हो गया आपका, ये जॉइंट हो गया आपका, ये जॉइंट हो गया, दीज आर द पिन जॉइंट्स, दीज आर द पिन जॉइंट्स. पिन जॉइंट्स बोले तो दे कैन नॉट रेजिस्ट एनी बेंडिंग मूवमेंट. आई एम अगेन रिपीटिंग, पिन जॉइंट बोले तो दे कैन नॉट रेजिस्ट एनी बेंडिंग मूवमेंट. अपार्ट फ्रॉम इट, इस स्ट्रक्चर के ऊपर किसी भी पॉइंट में ना कोई शेयर फोर्स होगा, ना कोई बेंडिंग मूवमेंट होगा, सिर्फ और सिर्फ एक्सियल फोर्स होगा. ओनली एक्सियल फोर्स विल बी एक्टिंग, ओनली एक्सियल फोर्स will be acting on a pin jointed structure, pin jointed structure. एक्सियल फोर्स बोले तो स्टूडेंट्स या तो वो कंप्रेशन होगा या वो टेंशन होगा. फॉर एग्जांपल इसकी मैं बात करूं, फॉर एग्जांपल इफ आई टॉक अबाउट द पिन जॉइंटेड स्ट्रक्चर, लेट अस से दिस इज अ मेंबर ऑफ द स्ट्रक्चर, या तो यहां पे टेंशन होगा एक्सियल फोर्स, या फिर यहां पे कंप्रेशन आपका एक्सियल फोर्स होगा. आइदर इट माइट बी कंप्रेशन, इट माइट बी टेंशन, राइट? यहां पे ना तो कोई बेंडिंग मूवमेंट होगा, ना ही आपका कोई शेयर फोर्स डेवलप होगा. ये प्रॉपर्टी है पिन जॉइंटेड स्ट्रक्चर की, ध्यान रखिएगा. एसएफडी और बीएमडी ड्रॉ करने में बहुत काम आने वाली है, राइट? सो दिस इज व्हाट द पिन जॉइंटेड स्ट्रक्चर्स आर. नाउ स्टूडेंट्स, इसके अलावा जो आपके स्ट्रक्चरल मेंबर्स हैं, अब ये जो आपके रिजिड जॉइंट्स हो गए, या रिजिड आपके स्ट्रक्चर्स हो गए, या आपके पिन जॉइंटेड स्ट्रक्चर्स हो गए, ये मेंबर्स से बने हुए हैं, राइट? अब ये मेंबर्स किस किस टाइप के होते हैं देखो स्टूडेंट्स, ये देखो जरा, ये जो आपका एक तो रिजिड जॉइंट हो गया, आपका रिजिड स्ट्रक्चर हो गया, ये वाला मान लो कि रिजिड जॉइंट हो गया, ये आपका पिन जॉइंटेड स्ट्रक्चर हो गया आपका. तो ये किसी ना किसी मेंबर से मिलके बने हैं ना स्टूडेंट्स, ये जो आपके मेंबर्स हैं, इनसे मेंबर से मिलके ही बने. अब ये मेंबर किन किन टाइप के हो सकते हैं, इसके बारे में बात करते हैं. सो फर्स्ट जो मेंबर है स्टूडेंट्स आपका, ये हो सकता है एक आपका बीम. सो बीम आपका एक तरह से फ्लेक्चरल मेंबर है. फ्लेक्चरल बोले तो कि ये आपकी बेंडिंग शो करेगा. फ्लेक्चरल का मतलब ही बेंडिंग होता है, राइट? फ्लेक्चरल स्टैंड्स फॉर बेंडिंग. फ्लेक्चरल का मतलब ही होता है बेंडिंग. स्टूडेंट्स ध्यान रखिएगा आप इसको, बेंडिंग. फ्लेक्चरल का मतलब ही बेंडिंग है. क्लियर? अगर आपसे कभी भी कोई एग्जाम में पूछे कि द फ्लेक्चरल स्ट्रेंथ का मतलब समझ जाना कि बेंडिंग स्ट्रेंथ की बात हो रही है. क्लियर? सो बीम इज अ फ्लेक्चरल मेंबर स्टूडेंट, जिसपे कि आप हमेशा ट्रांसवर्स लोडिंग लगाते हो. क्लियर? देखिए जरा स्टूडेंट्स, ट्रांसवर्स लोडिंग कैसे लगेगी. फॉर एग्जांपल ये आपकी बीम है, मैं आपको सामने से दिखा रहा हूं, ये आपको कोई भी सपोर्ट हो गया इस बीम के ऊपर, तो इसके ऊपर हमेशा आपकी ट्रांसवर्स लोडिंग लगेगी. ट्रांसवर्स बोले तो ये इसका लॉन्जिट्यूडिनल डायरेक्शन हो गया अलोंग द लेंथ. क्लियर? इसके परपेंडिकुलर जो डायरेक्शन, दैट इज कॉल्ड एज द ट्रांसवर्स डायरेक्शन. तो इस डायरेक्शन से जो भी आपकी लोडिंग लगेगी ऊपर से नीचे, दैट इज व्हाट इज कॉल्ड एज द ट्रांसवर्स लोडिंग. ये किसी एंगल पे भी हो सकती है, ये डायरेक्टली भी हो सकती है, कैसे भी हो सकती है, बट दैट इज व्हाट द ट्रांसवर्स लोडिंग इज ऑल अबाउट. क्लियर? तो ये आपका फ्लेक्चरल मेंबर है, ये ऐसे बेंड हो जाएगा. अब ऊपर से अगर आप लोड लगो तो ऑब्वियसली बात है, आप ऐसे बेंड हो जाएगी आपकी बीम, एंड दैट इज व्हाई इट इज कॉल्ड एज द फ्लेक्चरल मेंबर. क्लियर स्टूडेंट्स? सो नाउ अब बात करते हैं कॉलम. सो स्टूडेंट्स, कॉलम जो है आपका, इट इज अ कंप्रेशन मेंबर. कॉलम में हम लोग जब भी कॉलम को डिजाइन करते हैं, व्हेनेवर वी आर डिजाइनिंग एनी कॉलम, वी अज्यूम दैट व्हाटएवर द फोर्स इज एक्टिंग ऑन अ पर्टिकुलर कॉलम, दैट इज अ कंप्रेसिव फोर्स, बाय द वे, राइट? फॉर एग्जांपल, दिस इज अ कॉलम, दिस इज अ रिजिड सपोर्ट, this is a column. So whenever we design a column, we assume that all the forces are acting on the axis of this particular column, and all the forces are the compressive forces, until and unless the force is not acting at an eccentricity. If the force is acting at an eccentricity, obviously it is going to be some bending stresses will also be developed, that we'll be discussing in a later chapter, right? But generally we assume that the column is a compression member. It is only going to resist the compressive loads. Remember this thing, right? It is also going to be very helpful in solving a lot of numericals. After this, students, after understanding about the column, the next important thing is called as a strut. See students, there is a very little difference between the column and the strut. Column is also a compression member, strut is also a compression member, but strut can be a inclined member also, right? Column is always a vertical member, but the strut can also be an inclined member, and if the strut is a inclined member, there might be some extra bending movement might be developed, right? And the struts are designed for the compressive forces as well as for some bending movement also. So that is what the strut is all about. Then we have the beam column interface. So students, what is the beam column interface? So this is a column, this is again a column. On top of these two columns we have a big beam, right? So this structure is called as a beam column interface or the beam column combination structure. That is very, you can say, very basic thing. बिकॉज अगर कॉलम है तो कॉलम किसको सपोर्ट करेगा? स्लैब को सपोर्ट करेगा. द कॉलम मस्ट बी सपोर्टिंग द रूफ स्लैब, क्लियर। और रूफ स्लैब क्या है, वो आपका एक तरह से बीम की तरह काम करता है, इट एक्ट्स समवॉट लाइक अ बीम, राइट, and that particular beam, the load of that particular slab or beam is getting transferred to this column, and ultimately the load on the column is getting transferred to the ground. So that is what is happening. This is my ground here, right, this is ground here. So ये आपका बीम कॉलम का इंटरफेस है, बहुत ही सिंपल चीज है, क्लियर। नाउ स्टूडेंट, इसके बाद है आपका ग्रिड। तो स्टूडेंट्स, एक ग्रिड क्या है आपका? ग्रिड इज अ यू कैन से इट इज अ नेटवर्क ऑफ बीम इंटरसेक्टिंग एट राइट एंगल। सो यू मस्ट हैव फाउंड दैट, स्पेशली आपने देखा होगा कहां पे, स्पेशली आपने देखा होगा इंडस्ट्रियल रूफ्स में, राइट, इंडस्ट्रियल बिल्डिंग्स में, ये आपने देखा होगा, एक बीम आपकी ये जा रही है, एक बीम आपकी ये जा रही है, एक बीम आपकी ये जा रही है, एंड वन बीम इज गोइंग लाइक दिस, one beam is going like this, one beam is going like this, right? So this arrangement of all these beams intersecting at right angles, this is what is called as a grid, clear? This is what the grid is. So this is what the grid is. After the grid, students, we have the cables and arches. So cables and arches are the suspended members. They are suspended, you can say, from end to end they are suspended, right, and they are allowed to sag. Why do we use the cables and arches? So that without support a lot of long span can be stretched, right? आप ये केबल्स वगैरह क्यों प्रोवाइड करते हो? ताकि आप एक लंबा स्पैन बना सको ब्रिज का या किसी भी स्ट्रक्चर का, राइट, विदाउट गिविंग एन इंटरमीडिएट सपोर्ट. दैट इज व्हाई वी यूज द केबल, राइट, and that is why do we use the arches? So that the horizontal thrust can be reduced, the bending moment can be reduced with the help of the horizontal thrust. That is why we go for the arches. So that is a different topic. We are not going to discuss that thing in the strength of material, but that is although a very different topic, but still cables and arches are also said to be as one of the structural members. After this, students, we have the plates and slabs. So slabs, you already know that it is a, you can say, a three-dimensional slab, clear? The roof slab, I'm talking about the roof slab. So that is also a, you can say, structural member. Apart from it, we also have the plate, right? Plate is generally made up of metal, and metal, you can say that, for example, you must have seen that, for example, this is a column. अब इस कॉलम के ऊपर ये आपकी बीम लगी है, राइट? ये कॉलम जब स्टूडेंट्स ये जमीन के ऊपर अपना लोड ट्रांसफर करेगा तो यहाँ पे साइड में हम लोग प्लेट्स लगाते हैं, विच आर कॉल्ड एज द बियरिंग प्लेट्स, यार नीचे भी हम लोग प्लेट्स लगा देते हैं. तो दिस इज व्हाट द प्लेट्स आर ऑल अबाउट. क्लियर? चलिए. So these are the various types of structure, students, okay, which we come across in our day-to-day life, which we are going to discuss in the strength of material. We are not going to discuss the arches and cables in the strength of material. We are not going to discuss the plates and slab also. We are not going to discuss grid also. We are not going to discuss beam and column also. But yes, we are going to discuss about the columns. We are going to discuss about the beams in the strength of materials. So these are the two structural members which we are going to discuss in the strength of materials. Let us proceed further. The next thing is that, students, types of support. The first type of support that we have is called as the fixed support. Clear? So fixed support is very important to understand. Now, what is the fixed support? You must find that, you will find that a fixed support is generally represented like this. Like this. Clear? So this symbol, it denotes a fixed support, right? Now, what is the meaning of fixed support? Neither any translation motion can happen, neither any slope can be produced here. फॉर एग्जाम्पल, स्टूडेंट्स, आपने इस मार्कर को दीवार के अंदर धसा दिया, क्लियर, और आपने यहां से कॉन्क्रीटिंग कर दिया, यू हैव डन द कॉन्क्रीटिंग ऑल्सो, क्लियर, या फिर आपने वेल्डिंग कर दिया. मान लो कि स्टील का कॉलम था और ये आपकी स्टील की बीम थी और आपने यहां पे वेल्डिंग कर दिया. अब जब आप ट्रांसवर्स लोडिंग लगाओगे, स्टूडेंट, लेट अस से इट इज लाइक दिस. अंडरस्टैंड, व्हेन यू अप्लाई द ट्रांसवर्स लोडिंग, व्हाट इज गोइंग टू हैपन? क्या यहां पे कोई स्लोप जनरेट होगा? आप बोलोगे नहीं सर, ये क्या होगा? ये मान लो कि आपने यहां से इसको वेल्डिंग कर दिया, यहां से भी आपने वेल्डिंग कर दिया, और ये आपका मान लो कि कोई भी मेंबर है, अगर आप यहां पे कोई लोड लगाते हो, स्टूडेंट्स, तो यहां पे ये जीरो स्लोप होगा, यहां पे भी जीरो स्लोप होगा, बीच में हल्की सी आपको डिफ्लेक्शन आपको देखने को मिलेगी, समवॉट लाइक दिस. क्लियर? तो दिस टाइप ऑफ सपोर्ट इज सेड टू बी एज द फिक्स्ड सपोर्ट. क्लियर? क्लियर? ना तो ये आपको बीम को नीचे जाने देगी, ना ही आपके बीम को ऊपर जाने देगी, और ना ही यहां पे कोई स्लोप को डेवलप होने देगी. इसका मतलब ये मोमेंट को रेजिस्ट करेगी. दिस टाइप ऑफ सपोर्ट इज सेड टू बी एज द फिक्स्ड सपोर्ट. तो फिक्स सपोर्ट पे, स्टूडेंट्स, आपको क्या क्या देखने को मिलेगा? आपको ना तो कोई ट्रांसलेशन मोशन देखने को मिलेगा, ना ही आपको कोई रोटेशन देखने को मिलेगा. इट कैन नॉट रोटेट इन एनी डायरेक्शन. दैट इज द प्रॉपर्टी ऑफ द फिक्स्ड सपोर्ट. इट इज इंपॉर्टेंट फॉर सॉल्विंग मेनी क्वेश्चंस इन द स्ट्रेंथ ऑफ मटेरियल्स. आफ्टर दिस, स्टूडेंट्स, वी हैव द pinned supports. Clear? Now, what is a pinned support, students? Pinned support, it basically represented like this. It is represented like this. This is what the pinned support is. Clear students? Now if you apply some load from this direction, what is going to happen is that ये support ना तो नीचे जाएगी ना ये support horizontally जाएगी, कहीं नहीं जाएगी, right? लेकिन if you apply some load, यहाँ पे एक particular angle आपका theta आपका बन जाएगा, there will be a particular angle theta. It means that this type of support, it cannot resist any moment. ये कोई मोमेंट रेजिस्ट नहीं कर पाएगी, राइट? फॉर एग्जांपल जैसे कि घर में दरवाजा है, दरवाजे को अगर आप खोलोगे तो दरवाजा ऐसा तो नहीं है कि खुलता नहीं है, खुल जाता दरवाजा, राइट? बिकॉज जो दरवाजे की जो सपोर्ट है वहां पे जो आपने बोल्ट्स वगैरह लगाए हैं, जो आपने वहां पे मैकेनिज्म लगाया है, दैट इज बेसिकली अ पिन्ड सपोर्ट. क्लियर? इट कैन नॉट रेजिस्ट एनी मूवमेंट बिकॉज यू आर प्रोवाइडिंग अ मूवमेंट एक्चुअली, राइट? बिकॉज फॉर एग्जाम्पल स्टूडेंट, दिस इज अ डोर, ये आपका घर का दरवाजा है, दिस इज द हैंडल ऑफ द डोर. जब आप इस हैंडल को पकड़ के खींचते हो, यू विल फाइंड दैट this door moves about this particular point because you are applying some force in this direction. This is the distance d, so some movement is getting developed m, but this support cannot resist any movement and hence it opens. Clear? So ये आपका है pinned support. तो पिन सपोर्ट क्या करेगी स्टूडेंट्स? ये ना तो आपका हॉरिजॉन्टल डायरेक्शन में मूव करेगी, ना ही वर्टिकल डायरेक्शन में मूव करेगी, लेकिन हाँ, ये आपकी मूवमेंट को रेजिस्ट नहीं करेगी. इट कैन नॉट रेजिस्ट एनी मूवमेंट. This is important for the pinned support. I hope that you are getting it clear. After this, students, after understanding about the pinned support, you can find on this in this figure also that what is this pinned support. This is basically about you can say a bridge was being constructed, and from that particular bridge this photograph was taken. So this support is said to be as the pinned support. Clear? चलिए आगे बढ़ते हैं स्टूडेंट्स. आफ्टर दिस पिन्ड सपोर्ट वी हैव द रोलर सपोर्ट्स. रोलर सपोर्ट जो है जनरली आपको देखने को मिलेगी ब्रिज में. तो ब्रिज में होता क्या है स्टूडेंट्स? आपका फॉर एग्जांपल देखिए जरा, लेट अस से दिस इज अ ब्रिज, और इस ब्रिज के ऊपर जो है गाड़ी वगैरह चल रही है, सम व्हीकल इज मूविंग ऑन दिस पर्टिकुलर ब्रिज. नाउ एट दिस सपोर्ट यू विल फाइंड दैट सम रोलर्स आर बीइंग प्रोवाइडेड हियर. कुछ रोलर्स हम लोग प्रोवाइड करते हैं स्टूडेंट्स, राइट? ये रोलर्स क्यों प्रोवाइड किए जाते हैं ब्रिज में स्पेशली? बिकॉज अगर आप रोलर्स प्रोवाइड नहीं करोगे स्टूडेंट्स, तो एक हॉरिजॉन्टल थ्रस्ट एक एडिशनल जनरेट होगा. यू विल फाइंड दैट फॉर एग्जांपल, ये मैंने आपको एक फिगर यहां पे दिखाया है, अगर इसके ऊपर गाड़ी चलेगी, मान लो कि रोलर नहीं होता, इफ दिस वुड हैव नॉट बीन अ रोलर, ये आपने रोलर लगाया यहां पे, इफ दिस वुड हैव नॉट बीन अ रोलर, तो ये आपका अबटमेंट से जाके टकरा जाता, अबटमेंट से एकदम फिक्स रहता, और जब गाड़ी चलती, जो गाड़ी की वजह से जो गाड़ी का जो मोमेंटम है वो उसको क्या करता है, अबटमेंट को आगे पीछे धकेलने का ट्राई करता. बट दिस अबटमेंट इज अ फिक्स्ड सपोर्ट बाय द वे, राइट? ये तो फिक्स्ड है, तो कोई मूव नहीं कर रहा. इसका मतलब क्या है कि इस बीम इसके ब्रिज के अंदर एडिशनल हॉरिजॉन्टल फोर्स जो है डेवलप हो जाएगी, एंड दे माइट क्रिएट सम इफेक्ट ऑन द स्ट्रेंथ ऑफ दिस पर्टिकुलर ब्रिज. And that is why we have provided a roller support. रोलर से क्या होगा, अगर ये गाड़ी मूव करेगी तो गाड़ी की मोमेंटम की वजह से पीछे की तरफ या आगे की तरफ कुछ एक्स्ट्रा फोर्स लगेगा, तो अगर ये रोलर मूव करेगा तो अल्टीमेटली वो एक्स्ट्रा फोर्स आपका कैंसिल आउट हो जाएगा. ये वही बात हो गई. फॉर एग्जांपल, टू एवरी एक्शन देयर इज एन इक्वल एंड ऑपोजिट रिएक्शन. दिस इज अ फिक्स्ड सपोर्ट. अगर आप यहां पे बॉक्सिंग मारोगे स्टूडेंट, तो ऑब्वियसली बात है कि योर पंच विल आल्सो हैव द इक्वल एंड ऑपोजिट रिएक्शन. क्लियर? बट सपोज दैट दिस सपोर्ट इज मूविंग, this support is moving, what will have? You will not have the equal and opposite reaction, and that is why we use the roller supports. As simple as that. Clear? तो roller support का क्या फायदा हुआ स्टूडेंट्स? कि ना तो ये वर्टिकल डायरेक्शन में मूव करेगी, बट हाँ, ये हॉरिजॉन्टल डायरेक्शन मूव कर सकती है. इट कैन मूव इन द हॉरिजॉन्टल डायरेक्शन. Whether it will have some slope or not depends upon whether it is a fixed roller or whether it is a hinged roller. So this roller which I have shown you, it is a hinged roller. It might be a fixed roller also. For example, it might be a fixed roller also, like this. It cannot resist any moment. It cannot resist any moment. Clear? Depends upon whether the roller is a fixed roller or whether it is a hinged roller. Depending upon that, you can say that whether some movement will be generated or some movement will not be generated. Clear? But yeah, certainly it is not going to move in the vertical direction, but it is going to move in the horizontal direction. It means that it is free to move in the horizontal direction, and there will not be any type of horizontal thrust getting generated in the particular structure. So that is the effect of this particular thing. Clear? Roller support. Students, before proceeding further, let me tell you a very important thing. You can go for the textbook pass, students. So we have one pass for more than 100 plus courses. You will be getting an access to more than 6,500 plus mock tests. A lot of selections we have already made in different competitive exams. You will also be getting a good exam strategy as well as the expert guidance. And students, the textbook pass is only for ₹499 because मैं हमेशा recommend करता हूँ कि एग्जाम में एक्चुअल में जाने से पहले आपको मैक्सिमम नंबर ऑफ मॉक टेस्ट आपको सॉल्व करने चाहिए. So this is a very good thing. So you can solve maximum number of mock tests with the help of this. Clear? Also students, if you are preparing for the GATE Civil Engineering 2022 you can say exam, so आप जो है टेस्ट बुक की साइट पे जाकर के अपने लिए कोर्स ले सकते हो. इट इज अ पेड कोर्स बाय द वे, बट आई कैन हेल्प यू इन वन वे. ये जो आपके स्क्रीन पे जो आपको कोड नजर आ रहा है वरुण एंड द कैपिटल ऑफ के, इसका इस्तेमाल करके आप अपने लिए 10% 20% का डिस्काउंट आप अपने लिए फ्लैट ले सकते हैं स्टूडेंट्स. सो दैट इज व्हाट वी कैन डू फॉर यू. Also students, since it is a free series which is going on YouTube, the only motivation that we have got from your side is that you like, share and subscribe to the channel. That is the only thing that we have got from your side, is that you like, share and subscribe. Also you press the bell icon so that you can get the notification of all the newly added videos. चलिए स्टूडेंट्स आगे बढ़ते हैं. नाउ आफ्टर अंडरस्टैंडिंग अबाउट दीज फ्यू कॉन्सेप्ट्स दैट व्हाट इज दिस रोलर सपोर्ट, व्हाट इज दिस फिक्स सपोर्ट, राइट, लेट अस प्रोसीड फर्दर. अपार्ट फ्रॉम इट स्टूडेंट्स वी ऑल्सो हैव द सिंपल सपोर्ट. लेकिन सिंपल सपोर्ट सिर्फ और सिर्फ ये न्यूमेरिकल सॉल्व करने के लिए होती है, प्रैक्टिकली कोई सिंपल सपोर्ट नहीं है. आपने कभी ऐसा देखा है क्या कि दो दीवार के बीच में आपने स्लैब को रख दिया, या दो दीवार के बीच में आपने बीम को, कभी ऐसा होता है क्या? कभी नहीं होता है स्टूडेंट्स ऐसा, राइट. इट इज नॉट प्रैक्टिकल बाय द वे, राइट. It is just for the theoretical purpose that we have the simple supports. Now what is a simple support? आपने दो supports के ऊपर simply एक structure को रख दिया. Simple as that, right? For example, ये आपने कोई दो supports थी आपके पास, clear? और इसके ऊपर आपने एक beam को रख दिया. That is what the simple support is. Clear? Can it move in the upward direction? No. Can it move in the horizontal? No. Can it have a slope? Yes, it can have a slope. यहाँ पे आपका कोई slope आपका हो सकता है. That is what the simple support is. Or practical it is not possible. I think I have written it here also. Simple supports are not widely used in real life structure. They are not used unless the engineer can be sure that the member will not translate. Engineer is never sure, right? I'm telling you that even if an engineer has made a very brilliant structure, even then it has a lot of probability that the structure might fail due to n number of reasons which the engineer might not have taken into consideration, or which might be some accidental, you can say some accidental failures might also be there. Clear? Otherwise they run the risk of the family of the member simply falling off the support. Clear? That is what the simple support is all about. It is not practical, it is only theoretical. It is only theoretical, not practical. Clear? As simple as that. Now students, after understanding the various types of support, it is important to understand the various types of loads. So generally we have three types of loads. One is called as a point load, or which is also called as the concentrated load. Apart from it, you can have the distributed load, and the distributed load can also be of two types. It can be a uniformly distributed load. It can be a uniformly varying load also, right? Which is also called as a triangular load, or the parabolic load, or circular loading also. Clear? Uniformly varying load. Apart from it, you can also have a coupled load also. So these are the various types of loads which you can have on a particular structure. Now what are the various types of loads? First of all, the point load. Point load, for example, this is a beam. On this beam, the nib of this marker is said to be as a point load. If you apply some load with the help of nib of this marker, the nib of the marker, it you can say occupies a very small area. The area is almost negligible. It occupies a very small area, and that type of loading is said to be as the point loading. Clear? Now the question is that, sir, practically what type of loading is a point loading? For example, there is a very big bridge and you are walking on the bridge. So students, compared to the size of the bridge, the area of your foot which you are placing on the bridge is very small. So your load is said to be as a point load. Clear? That is what the practical significance of the point load is. Clear? अगर आप एक ब्रिज के ऊपर वॉक करो, ब्रिज तो बहुत बड़ा है, ब्रिज के एरिया के कंपैरिजन में आपके पैरों का जो एरिया इट इज वेरी स्मॉल, सो दैट लोड इज सेड टू बी एज द पॉइंट लोड. क्लियर? प्रैक्टिकली. सो पॉइंट लोड क्या है कि अगर आपका लोड एक बहुत ही छोटे से एरिया पे कंसंट्रेट होके एक्ट करता है, दैट पर्टिकुलर लोडिंग इज सेड टू बी एज अ पॉइंट लोडिंग. फॉर एग्जांपल, इट इज शोन लाइक दिस. लेट अस से ये आपके पास कोई बीम है, इट माइट बी अ ब्रिज और एनीथिंग, ये आपका कोई सपोर्ट हो गया, दीवार हो गई कोई सपोर्ट, और ये एकदम ऐसे एरो करके, जब भी आपको एरो करके एग्जाम में कोई एरिया आपको वो लोड दिखाया जाएगा ना, समझ जाना कि ये पॉइंट लोडिंग है, बहुत ही छोटे से एरिया पे एक्ट करता है. द एरिया डज नॉट हैव अ बिग पिक्चर टू प्ले और बिग रोल टू प्ले. Clear? So that is what the point loading is. It is also called as the concentrated load also, one and the same thing. Apart from it students, you can have the distributed load also. Distribute का आपको समझ में आ गया कि ये पूरे बीम के ऊपर या पूरे मेंबर के ऊपर डिस्ट्रीब्यूटेड है. डिस्ट्रीब्यूटेड बोले तो कि ये एरिया बहुत ज्यादा ऑक्यूपाई करता है. अगर एरिया बहुत ज्यादा ऑक्यूपाई कर रहा है स्टूडेंट्स, इट मींस दैट यहां पे आपको फिर कुछ दूसरा फंडा अपनाना पड़ेगा. ले वो मैं आपको बताऊंगा वो फंडा क्या है, कि आप उसको कैसे निकाल सकते हो, उसकी इंटेंसिटी आप कैसे निकाल सकते हो. आई विल बी टेलिंग यू दैट आल्सो, डोंट हैव टू वरी. बट द डिस्ट्रीब्यूटेड लोड माइट आल्सो बी ऑफ टू टाइप्स. एक है आपका स्टूडेंट्स यहां पे डिस्ट्रीब्यूटेड लोड, एक है आपका यूनिफॉर्मली डिस्ट्रीब्यूटेड लोड, एंड वन इज द यूनिफॉर्मली वेरिंग लोड आल्सो, राइट. नाउ यूनिफॉर्मली डिस्ट्रीब्यूटेड लोड इज जनरली represented like this, clear, and uniformly varying load is generally represented like this, clear. It might be this type of triangle, it might be this type of triangle, clear. It might be a semicircle also, it might be a semicircle also, it can be anything, it can be parabolic also, doesn't matter, it can be any type of loading, it can be, clear. This is what the uniformly varying load is all about. So you can easily think that it is basically distributed over an area, and if it is distributed over an area, how do we have to get the intensity of that particular loading? I will be coming to that particular topic also, clear. So that is what the distributed load is all about. I hope that you are getting it students, right? It is a very simple thing that you are getting it. I am teaching you right now. After this students, we can have the coupled load also. Now what is this coupled load? If a movement is acting, or if a couple is acting on a particular, you can say a member, let us say this is a member like this, okay, and this has somewhat like this, some load is acting here, some load is acting here. So obviously students, if this is the load P, this is also the load P, so they are, let's say this is equal to D and this is also equal to D. So at this particular point, they are also creating a couple also, which is equal to 2 into P into D. As simple as that, right? So एक इस तरह का भी आपका लोड जो एक्ट कर सकता है किसी मेंबर के ऊपर, क्लियर. या फिर आपको ऐसे बोल दिया कि अच्छा ठीक है जी, ये आपका ऐसे एक्ट कर रहा है और यहाँ पे एक कपल लगा दिया आपने, ऐसे भी कर सकते हो आप इसको, राइट. दैट इज व्हाट द कपल लोड इज. आई होप दैट यू आर गेटिंग क्लियर. चलिए, नाउ स्टूडेंट्स, आफ्टर दिस कपल लोड, let us understand how do you calculate the support reactions for various load conditions. It is important to understand the various concepts of the strength of material. So let us understand it. For example students, example number 1, ये support reactions कैसे निकालने हैं students? आपको बस तीन चीजों का हमेशा ध्यान रखना है. Summation of fx is equal to 0, summation of fy is equal to 0, and the summation of the moment is equal to 0. For a particular member to be in the static equilibrium, these three conditions always have to be satisfied. Summation of fx 0, summation of fy 0, and the summation of the moment is equal to 0. Clear? Now students, let us directly solve some examples and you will come to know how can you solve the various types, how can you get the support reactions for the various types of load conditions and for the various types of support conditions. Let us understand. Let us start with a very simple thing. This very simple thing is about a simply supported beam. Just wait a second. Now let us start with a very simple thing. So question, a beam is there. Now on this particular beam, one point load is this is 10 kilonewton. One point load is here, which is again 20 kilonewton. For example, this is 20 kilonewton. This distance is 1 meter. This distance is 2 meters, and this distance is 3 meters. So students, you have to find, this is my A, this is my B. You have to find the reaction at A and reaction at B. So students, how can we solve it? Solution. So first of all, we have to go with summation of Fy is equal to 0. That the vertical forces should be equal to 0. So you will find that reaction at A plus reaction at B, it is equal to nothing but 10 plus 20, that is equal to 30 kilonewton. This is my reaction at A plus reaction at B is equal to 30 kilonewton. As simple as that, right? Now students, you can take the moment about any of the support equal to 0. The question is, sir, why do I have to take the moment about any support equal to 0? Because from this particular figure, you will find that this is also a pinned support and this is also a pinned support. If both the supports are the pinned support, what do we have to do is that you can take the moment about any of the point equal to 0. As simple as that. Clear? So students, now taking the summation of the moment about, let us say, equal to b equal to 0. So you will find that this RA, this is my RA. Let me take a different marker here. Just wait a second. This will take a different marker here. Yes. Yes. So this is my RA. This is my RB. Now students, RA multiplied by how much? 2, 3, 4, 5 into 6 minus 10 into 5 minus 20 into 3 is equal to 0. Now let me make you understand how is it RA into 6 minus 10 into 5 minus 20 into 3. See students, in this particular diagram, you will find that the reaction at A is making a movement of clockwise about the point B. So आप देखो जरा बड़े ध्यान से, अगर ये RA है आपका, ये आपका RA हो गया, इस पॉइंट के अबाउट ये कौन सा मोमेंट लगा रहा है? देखो जरा, ये आपका RA है, ये आपका RB है यहाँ पे. क्लियर? इस पॉइंट के अबाउट आर ए कौन सा मूवमेंट लगा रहा है? आर ए क्लॉकवाइज मूवमेंट. एंड आई हैव ऑलरेडी टोल्ड यू दैट द क्लॉकवाइज मूवमेंट इज ऑलवेज टेकन एज पॉजिटिव, एंटी क्लॉकवाइज मूवमेंट इज ऑलवेज टेकन एज नेगेटिव. क्लियर? और यू कैन से दैट द सैगिंग मूवमेंट इज ऑलवेज टेकन एज पॉजिटिव, द हॉगिंग मूवमेंट इज ऑल्सो टेकन ऑलवेज टेकन एज पॉजिटिव. सो यू विल फाइंड दैट अबाउट दिस पॉइंट बी, दिस आर ए इज मेकिंग अ सैगिंग मूवमेंट. ये इसको सैग करने का ट्राई कर रहा है. इट इज ट्राइंग टू मेक दिस particular point be somewhat like this, so that is a sagging moment, and that is why it is taken as positive. Clear? Similarly, 10 minus 10 into 5. Why is it minus 10 into 5? See students here, why it is minus 10 into 5? Why not plus 10 into 5? Because you will find that this point, this 10 kilonewton load about this point B is creating an anti-clockwise movement. Clear? Or it is trying to make this point be somewhat like this hogging movement. And that is why I have taken it as negative. Clear? Same goes with the 20 kilonewton load also. It is also trying to make an anti-clockwise movement or trying to make a hogging movement about the point B. And that is why it is taken as negative. Similarly, here it is negative minus 20 into 3 is equal to 0. And from here you can easily get the value of RA, right? So what will be the value of RA? RA is going to be 10 into 5 is 50, 20 into 3 is 60, 60 plus 50 is 110, so 110 divided by 6 is the value of this RA. Now you can put the value of this RA in this particular equation and you can get the value of RB also, not an issue in that. Clear? So that is how students you can calculate the support reaction. This was a very simple question which I had given you. It was a very simple question. Clear? So that is how students you can easily calculate the various types of support reactions. Now students, if the note here, you can note here, note. Just wait a second. Note here. The note is that students, if the structure is symmetric, the load is distributed evenly. Let us understand what is the meaning of this symmetric structure is. Clear? So students, for example, this is a beam. Let us say this is a beam. On this particular beam, this is a load which is acting 10 kilonewton here. This is equal to 5 meter and this is also equal to 5 meter. So students, now this structure is symmetrical. Why? Because आपकी support भी same है दोनों side में. Clear? आपका load force is getting distributed at the two particular supports. क्लियर? इंपॉर्टेंट है, ध्यान आएगा, काम आएगा आपको. कई बार आपको जो है रिएक्शन निकालने की जरूरत ही नहीं, आप स्ट्रक्चर को देखो, अच्छा सिमेट्री कर दो, डिवाइड बाय 2 कर दो, खत्म काम. क्लियर? चलिए आगे बढ़ते हैं. लेट अस सॉल्व वन मोर क्वेश्चन. क्वेश्चन इज, वन बीम इज देयर. ऑन दिस पर्टिकुलर बीम, लेट अस से दिस इज अ somewhat like this and this is a roller support. Now students, on this particular beam, you have a UDL here and then you have a UVL here. Clear? The intensity of the UDL is 5 kilonewton per meter. Intensity of this UVL, it starts from 0 and it goes to a maximum value of how much? Let us say it is 10 kilonewton per meter. This length is 5 meters and this length is 6 meters. Clear students? Now you have to find the reaction at A and reaction at B. That is what you have to find. How do you have to find it? Very simple. First of all, summation of vertical force is equal to 0. Solution. Summation of vertical force. So RA is going in the upward direction, RA. RB is also going in the upward direction, RB. Now 5 is coming in the downward direction, 10 is also coming in the downward direction. But these are not the concentrated loads. These are the uniformly distributed and the uniformly varying loads, or I can say these are the distributed loads. So students, always remember that whenever you have a distributed load, okay, then you have to multiply the area of the distributed load with the length of the particular, or you have to calculate the area of the distributed load, and hence you can get the value of the resultant force. What is the meaning of this? See, for example, for this UDL is acting in the downward direction, so minus 5 into the length of the UDL is how much? 5. As simple as that. Minus, now this UVL also acting in the downward direction, so that is a minus area of this triangular loading, half into base is 6 and into height is 10 is equal to 0. Clear? So students, you can say that RA plus RB is equal to 5 into 5 is 25 plus, so 2 into 3 is 6, 10 into 3 is 30. So this is going to be 55 kilonewton. That is my RA plus RB. This is going to be 55 kilonewton, equation number 1. Now we have two unknowns here, RA and RB, but equation only 1 we have. It means that you cannot find the value of RA and RB until and unless you do not have any other condition. Clear? What is any other condition? So you will find that this is a hinged support, and I have told you that hinge support cannot resist any bending moment. So you can take the moment about this particular hinge support B or A also, because A is also a hinge support, equal to 0. Clear? So what is the next thing? The next thing is that taking the moment about point B is equal to 0. Now understand very carefully which is positive, which is negative. So RA into 11, I hope that you are getting it. Why it is RA into 11? Because it is acting in the clockwise manner. It is trying to make this beam in the sagging position, and that is why it is positive. So RA into 11, RA into 11 minus, see here, this particular point loading UDL, 5 into 5 is the resultant, and the resultant of a uniformly distributed load or just a distributed load always acts at the centroid of the particular load. Clear? Always remember this thing, that the resultant of a distributed load always acts at the center of the distributed load. Not the center, but the centroid of the distributed load. Clear? Now एक line का centroid क्या होगा? Line के आधे पे. Clear? So the resultant of this UDL will be lying at the center. It means that 2.5 from here and 2.5 from here. I hope that you are getting it. Clear? So it will be equal to minus 5 into 5 into minus 5 into 5 into bracket, you have 6 plus 2.5. I hope that you are getting it. Why it is 6 plus 2.5. यहां पे कोई भी डाउट होगा स्टूडेंट्स आप मेरे से पूछ लेना, ठीक है. सिमिलरली माइनस हाफ इंटू बेस इंटू हाइट, क्लियर, एंड मल्टीप्लाइड बाय, सी the centroid of the triangle always acts at a distance of depth divided by 3 from the base and 2 times of depth divided by 3 from the vertex side. So from here to here the distance is going to be 6 divided by 3 into 6 divided by 3. So from here you can easily get the value of this RA. This is equal to 0. Summation of moment about the point B equal to 0. Clear? So from here, students, you can easily get the value of this. That is your reaction at A. So what is going to be the reaction at A? Let me use the calculator. So this is going to be 3 into 2 is 6. 2 and 2 will get cancelled out. 10 into 6 is 60. So it is going to be 60 and plus 25 into 8.5. So and divided by 11. So RA is going to be 24.77. So RA is going to be 24.77 kilonewtons, the value of this RA. Similarly, students, you can get the value of RB also. You can put it in this formula, minus 55. So RB is equal to 30.22. So RB is equal to 30.22 kilonewton. So from that is how, students, you can get the value of RA and RB. I hope that you have got it. How can you calculate the support reactions very easily? Clear? Now let us move to the shear force diagram and the bending moment diagram. Apart from it, there might be n number of cases that we will be discussing when I will be drawing the SFD and the bending moment diagram. There might be n number of cases apart from it. Clear? Now students, let us go to the SFD and BMD. So SFD and BMD basically gives you the distribution of the shear force and the distribution of the bending moment, by the way. Clear? Now, before understanding that how the shear force and how the bending moment is getting distributed in a particular structure, it is important to notice this particular table. That is, for a point load, the shear force diagram is going to be a rectangle and the bending moment diagram is going to be a triangle. For a uniformly distributed load, the shear force diagram is going to be a triangle, the bending moment diagram is going to be a parabola, that is a 2-degree curve. For a UVL, the shear force diagram is going to be a parabola, that is a 2-degree curve, and the bending moment diagram is going to be a cubic parabola, that is a 3-degree curve. Now, what is the meaning of this? Let us understand it. For example, friends, question number 1. This is a simply supported beam, somewhat like this. On this particular simply supported beam, you have a load capital W acting at the center. Clear? And this distance is L by 2 and this distance is also L by 2. I am starting with a very simple example, then we will be proceeding later on, we will be proceeding with a higher difficulty level questions also. So students, since this structure is symmetrical, let us say this is my A, this is my B. So you will say that reaction at A is equal to reaction at B, it is equal to nothing but W by 2, as simple as that. The first point is this. The reaction at A divided by reaction at B is equal to W by 2. Now, let us draw the shear force diagram. That is the distribution of the shear force. So, draw this line. Now, at this particular point A, what is the shear force? You will say, sir, it is W by 2 acting in the upward direction. So, I will draw a line here acting in the upward direction like this. And this value is W by 2. Now, from this point A to the point C, let us say this point is C. Is there any load acting? There is no load acting. So, the shear force diagram is going to be a horizontal line like this. It will not change. The shear force will not change. Up to this point, it will not change. Let us say this point is C. Clear? It will not change. It is going to be same here. Now, at this particular point C, यहाँ पे इसकी वैल्यू क्या थी आपके पास W by 2, it was acting in the upward direction and W is acting in the downward direction, so minus W. So this is going to be minus W by 2. So इस वाले point C पे इसकी वैल्यू क्या हो गई? Minus W by 2 हो गई. It has become minus W by 2. So minus W by 2 will be downward here. So this value is minus W by 2. This value is minus W by 2. Now from C to B, is there any force? Whether it is a UDL, whether it is a point load? No. So it is going to be again a straight line like this. And again at this particular point B, say this point, this W is W by 2. So minus W by 2 and plus W by 2, it is going to be 0 here. So this is what the shear force diagram is all about. This is my positive and this is my negative. In some books, you will find that this is taken as positive, this is negative. That is also perfectly fine, doesn't matter. Clear? That is also perfectly fine. Because the sign convention depends upon person to person. How a person takes a particular sign convention, it depends upon him or her. Clear? So this is what the shear force diagram is all about. I hope that you have got it, students. How can you draw the shear force diagram or the SFD of this particular structure. Now, before proceeding to some more type of structures, some more difficult problems, let me tell you a very important thing, students, that I always recommend that before going for any competitive exam, you should give n number of mock tests. So you can go for the textbook pass. So we have one pass for more than 100 plus courses. You will be getting an access to more than 6,500 plus mock tests. A lot of selections we have already made in different competitive exams. You will also be getting a good exam strategy as well as the expert guidance. And the textbook pass is only for rupees 499. So it is once in a lifetime sale which is going on right now. So students, आप इसका जाकर के फायदा उठा सकते हैं. Also students, if you want to prepare for the GATE Civil Engineering 2022 exam, then you can go to the textbook site. You can buy the course for you. It is a paid course, but I can help you in one way. You can enter this coupon code which is flashing on your screen right now. That is Varun and a capital of K, and you will be getting a flat discount of around 20%. Also students, since it is a free series which is going on YouTube right now, so you should like, share and subscribe to the channel. That is the only motivation that we have got from your side, is that you like, share and subscribe. So I hope that you now know that how can you draw the shear force diagram. I had taken a very simple, you can say simple question here. Now let us take some difficult questions also. So students, let us take some difficult questions. Question number 2. Now let me take again a simply supported beam, somewhat like this. On this simply supported beam, let us say you have a UDL here. Clear? And this particular thing is justified from here also. That how can you draw the shear force diagram? The shear force diagram for a point loading is what? It is a rectangle here, and we have got the rectangle, right? We have not drawn the bending moment diagram right now, because currently I am just focusing on the shear force diagram. Then I will be coming to the bending moment diagram also. So students, for example, this is a UDL. It is a it is a uniformly distributed load. It is symmetric also. The beam is also symmetric. Clear? This point is A. This point is B. So I will say that if it is symmetric, RA will be equal to RB will be equal to, let us say the intensity of this UDL is W kilonewton per meter, and the whole length is L. So you will say that, sir, this is equal to W into L divided by 2. As simple as that. W into L divided by 2. Clear? Now if you want to draw the shear force diagram, you will find that here the shear force is W into L by 2 at the location of point A. Clear? At this point you will find that if you keep on subtracting it, since it is a UDL, so it is going to be a triangle in nature. So it will go somewhat like this, and here it will become minus W into L by 2. So this is going to be the shear force diagram. This is what the shear force diagram is all about. Clear? Now students, let us go to the bending moment diagram. So in this particular scenario, if you have a loading like this, L by 2, L by 2. So students, if you want to draw the bending moment diagram, shear force diagram we already know. That is, this is what the shear force diagram is all about. Clear? If you want to draw the bending moment diagram, students, you will find that what is the bending moment at this particular point? You will say, sir, it is equal to 0. What is the bending moment at this particular point? You will say, sir, it is also equal to 0. What is the bending moment at this particular point? You will say, sir, it is equal to W by 2 into L by 2. That is WL by 4. So here it is WL by 4. WL by 4, and it is going to be a triangle, so join these 3 points. So this is what is going to be the bending moment diagram for this type of structure. Similarly, for the UDL case, this was the UDL case here, this is a UDL case. What is the shear force diagram? The shear force diagram was somewhat like this, as simple as that. Now what is the bending moment diagram? What is the bending moment at this point? You will say, sir, it is equal to 0. What is the bending moment at, let me turn off my video profile, because it has gone beyond my this. So what is the bending moment at this particular point? You will say, sir, it is equal to 0. Now what is the bending moment at this particular point? That is the center of this particular thing. You will say, sir, it is equal to, this is my WL by 2. Clear? You will say, sir, it is equal to, bending moment at C is going to be W into L by 2 into L by 2 minus W into L by 2 into L by 4 and that will be equal to WL square by 8. Clear? So this is going to be WL square by 8 and it is going to be a parabola. So you join these three values. So this is going to be the value of the shape of the bending moment diagram. So this is my bending moment diagram and this value, maximum value is equal to WL square by 8. The question is, sir, ये आपने किया क्या? What have you done here? What have you done here? See students, you want to calculate the bending moment at this point. So this is W into L by 2 in the upward direction. It is making a clockwise moment about this particular point. That is W into L by 2 into L by 2. Clear? So W into L by 2 into L by 2. Minus, why minus? Because you also have this UDL also. This much of UDL. W, the intensity of this UDL into L by 2 and the resultant of this UDL, half UDL will be acting at the center. This will be equal to WL, this will be equal to L by 4. So that is why it is W into L by 2 into L by 4. That will be equal to WL square by 8. So WL square by 4 minus WL square by 8, it is going to be WL square by 8. So that is why you have got the value that is equal to WL square by 8. Clear? I hope that you have got it. How can you draw the bending moment and the shear force diagram? And that is also, you can see from this particular table also. So if it is a UDL, the shear force diagram is going to be a triangle and the bending moment diagram is going to be a parabola of 2 degree. It is a parabola of 2 degree. Clear? That is also justified from this also. So this point number 2. क्लियर? आई होप ये आपको समझ में आया स्टूडेंट्स, यू हैव गॉट इट. बहुत ही इजी कंसेप्ट है ये वाला, ठीक है ना. एकदम मैं जीरो से एकदम स्टार्ट किया है. आई नो आप में से काफी लोगों को ऑलरेडी पता होगा एसएफडी और बीएमडी कैसे ड्रॉ करते हैं, हाउ डू वी ड्रॉ द एसएफडी एंड बीएमडी, बट स्टिल इवन इफ यू डू नॉट नो एट ऑल कि कैसे ड्रॉ करना है, आई हैव टोल्ड यू दैट. चलिए स्टूडेंट्स आगे बढ़ते, लेट अस प्रोसीड फर्दर. नाउ let me turn off my video profile. Chale. Now students, let us understand a very important term which is called as the point of contraflexion and the shear span. See students, what is point of contraflexion? The point at which the bending moment changes sign is called as a point of contraflexion. For example, you have a fixed beam somewhat like this. You have a fixed beam somewhat like this. You have some load acting at this particular point. Now, if you draw the bending moment diagram, you will find that the bending moment diagram is going to be somewhat like this. Clear? The question is, sir, how we have got this bending moment diagram? Don't worry. In the subsequent lectures, I will be telling you how can you draw the bending moment diagram for these types of structures also, right? The bending moment diagram is going to be somewhat like this. So students, you will find that this is negative here, this is positive here. So here at this particular point, you have the bending moment is equal to 0. And at this particular point, the bending moment is changing sign also. From negative, it is becoming positive. Clear? So this point is called as the point of contraflexion. Clear? Now, how can you get the value of point of contraflexion? Where do we have the point of contraflexion? By putting bending moment is equal to 0. From there, you can have the point of contraflexion. Clear? The question is, sir, what is the फिजिकल सिग्निफिकेंस ऑफ पॉइंट ऑफ कॉन्ट्राफ्लेक्चर? कि चलो ठीक है, बेंडिंग मोमेंट मेरा 0 से पॉजिटिव आ रहा है, इसका फिजिकल सिग्निफिकेंस क्या है? मैकेनिकल और सिविल के लिए फिलहाल सॉम में आप इतना ध्यान रखिए, इसका फिजिकल सिग्निफिकेंस आता है थ्योरी ऑफ कॉलम्स में. थ्योरी ऑफ कॉलम्स में देयर इज अ टर्म व्हिच इज कॉल्ड एज द इफेक्टिव लेंथ. सो इफेक्टिव लेंथ इज द लेंथ बिटवीन द टू पॉइंट्स ऑफ कॉन्ट्राफ्लेक्चर, राइट? और वो पॉइंट ऑफ कॉन्ट्राफ्लेक्चर क्या होता है? जहां पे बेंडिंग मोमेंट अपना साइन चेंज करती है या फिर बेंडिंग मोमेंट आपकी 0 होती है. दैट इज व्हाट द पॉइंट ऑफ कॉन्ट्राफ्लेक्चर इज. क्लियर? नाउ स्टूडेंट्स, What is the shear span? एक ऐसा span जहां पे आपकी shear force constant है. For example, just now we draw the shear force diagram. So this shear force was constant here. So this span is called as the shear span. Clear? This is what the shear span is all about. In some books, you will find that the shear force is 0. No, that is not the shear span. Where the shear force is constant, that is what is called as the shear span. I hope that you have got it. Clear? For example, आपके पास कोई ऐसी loading है. Let us say that you have loading somewhat like this. This is W and this is also W, like this. Clear? So this is going to be W here, this is going to be W here. If you draw the shear force diagram, W, then 0, then 0 and then this. So you have this shear span, this shear span, this shear span. Clear? You have 3 shear spans. So that is what the shear span is all about. चलिए स्टूडेंट्स, काम आएगा आपको बाद में, ठीक है ना? आपको बाद में काम आने वाला है. चलिए आगे बढ़ते हैं. Let us solve some question, students. One more question. Question is, a beam is given to you, simply supported beam, and on this simply supported beam you have this UDL somewhat like UVL, somewhat like this. The maximum intensity of this UVL is W. This is your L. Yeah, you have to find the reaction at A, you have to find the reaction at B, you have to draw the SFD, you have to draw the BMD also. Now कैसे करेंगे इसका? अब देखिए ये स्ट्रक्चर सिमेट्रिकल नहीं है. Why? Because it is uniformly varying load is not symmetrical. So I will say that RA plus RB, it is going to be half into base into height. Clear? Now taking the moment about the point B is equal to 0. This is my point A, this is my point B. Taking the moment about the point B equal to 0. So RA into L minus half into L into W by 3, into L by 3 into L by 3 is equal to 0. So RA is going to be, this is going to be WL square by 6, so WL by 6. Clear? If this is WL by 6, RB is going to be WL by 2 minus WL by 6. So taking 6 as the LCM, 2 into 3 is 6 minus 1, that is W into L by 3. W into L by 3 is the value of RB. So we have got RA, WL by 6, we have got RB also, WL by 3. So we have got both RA and RB now. Clear? Now students, what we can do is that, first of all, now we have to draw the SFD. So SFD, here it is WL by 6, it is acting in the upward direction. So WL by 6. Clear? Now students, it is WL by 6 and we know that if it is a UVL, see here I have told you that also, if it is a UVL, the SFD is going to be a 2-degree parabola. So it is going to be somewhat like this. Going to be somewhat like this. Clear? So this is going to be the SFD. And this is a 2-degree parabola. 2-degree parabola. Clear? It is going to be somewhat like this. Now similarly, the bending moment diagram. Now students, we know that the bending moment diagram in case of a UVL is going to be a cubic parabola. एंड स्टूडेंट्स शेप वाइज अगर मैं बात करूं तो क्यूबिक पैराबोला क्या है और आपका 2 डिग्री पैराबोला क्या है, शेप वाइज आपको समझ में नहीं आएगा जब तक कि आपको इसकी इक्वेशन नहीं पता. until unless you do not know the equation of the parabola, you will not be able to distinguish between the cubic parabola and the 2 degree parabola. So शेप वाइज वो दोनों देखने को सेम एक ही जैसे आपको देखने को मिलते हैं. क्लियर? सो अगेन हियर तो bending moment at this point A was equal to 0, it was a hinge point, and the bending moment at point B is also equal to 0. The bending moment is going to be somewhat like this. So this is going to be a 3-degree parabola. 3-degree parabola. Clear? So this is important to know that how can you draw the 2-degree parabola and the 3-degree parabola. देख के आपको दोनों की शेप एक जैसी लगेगी, लेकिन जब तक कि आपको इक्वेशन नहीं दी एग्जाम में तब तक आपको मुश्किल हो जाएगा. एक चीज और ध्यान रखिएगा, ऑलवेज रिमेंबर वन थिंग स्टूडेंट्स, वेरी इंपॉर्टेंट. द स्लोप ऑफ द shear force diagram, the slope of the bending moment diagram always gives you the shear force. V is the shear force. The slope of the shear force diagram always give you the intensity of the loading. Always remember these 2 points. These 2 points will be very helpful in drawing the SFD and BMD. Also, these will be helpful in the conjugate beam method also. Conjugate beam method, which I'll be telling you later on in the deflection of beams, that how can you calculate the deflection with the help of the conjugate beam method. वहां पे भी आपको काफी हेल्प करेगा. और अभी भी ये काफी इंपॉर्टेंट है कि अगर आपने स्लोप निकाला बेंडिंग मोमेंट डायग्राम का तो वो आपको शेयर फोर्स देगा, और अगर आपने स्लोप निकाला शेयर फोर्स डायग्राम का तो वो आपको रेट ऑफ लोडिंग देगा. क्लियर? दैट विल गिव यू द रेट ऑफ लोडिंग बाय द वे. तो इट इज इंपॉर्टेंट स्टूडेंट्स फॉर द कॉम्पिटिटिव एग्जाम पॉइंट ऑफ व्यू. आप 2 मिनट में कोई भी एसएफडी और कोई भी बीएमडी आप इसकी हेल्प से आप बना सकते हो. सो इट इज इंपॉर्टेंट. क्लियर? नाउ स्टूडेंट्स, let us solve some questions. The first question is, for the uniformly distributed loading on a simply supported beam as shown below, the support reaction at support A is equal to how much kilonewton? It is very simple question, students, by the way, right? So how can you get it? So it is very simple. First of all, RA plus RB is going to be half into base. Base is how much? 10 plus 5 is 15. Half into base into height is 15 into 15. So RA plus RB is going to be how much? This is going to be 15 into 15 into 15 into 25 divided by 2. This is going to be RA and RB. Now students, what we can do is that you can take the moment about the point B equal to 0. How can you take the moment about the point B equal to 0? Just this, RA. Clear? Or you can, yes, you can do one thing, or you can do one more thing also, that what you can do is that you can take the moment about point A also equal to 0. That is also the scenario. You can get it. You can take the moment, that will be much more easier. You can take the moment about the point A is equal to 0. If you take the moment about the point A equal to 0, you will be getting RB into 10 minus half into 10 into 15, half into 15 into 15 multiplied by 2 by 3 of 15. 2 by 3 of 15. So students, this is going to be RB is going to be, let me use my calculator. So this is 2 get cancel out. 3 into 5 is 15. 5 is there. So 15 into 15 into 5. This is going to be this much divided by 10. RB is going to be 112.5. 112.5 kilonewton. This is the value of RB. You can put the value of RB in this equation, that is minus 15 square divided by 2. So student, this is going to be equal to 225 divided by 2. This is going to be 112.5 kilonewton. Clear? And students, RB is also equal to 112.5 kilonewton. So you will find that the RA will be equal to 0. As simple as that. I hope that you have got it right. You will say that, sir, how this RA is equal to 0? Because now it has become just like a fulcrum, right? Fulcrum बोले तो कि आपने एकदम बीच में आपने बैलेंस कर दिया पॉइंट बी को, एकदम आपने पॉइंट बी को एकदम बीच में बैलेंस कर दिया. क्लियर? एंड दैट इज ऑल्सो जस्टिफाइड बिकॉज ये जो आपका टोटल ट्राइंगुलर लोडिंग है, आप इसको ध्यान से देखिए, ये जो पॉइंट बी है उसके सेंट्रॉइड पे एक्ट करता है. आई होप यू आर गेटिंग इट. क्लियर? बिकॉज टोटल जो लेंथ है इसका ट्राइंगुलर लोडिंग का, दैट इज इक्वल टू 15 मीटर्स. लेट मी यूज द डिफरेंट मार्कर हियर. So that is equal to 15 meters. From here you will find that this total is equal to 15 meters. 15 meters. यहाँ से लेकर के यहाँ तक. And friends, you will find that this point B is at the centroid है, right? Centroid पे एक्ट करता है आपका. तो सेंट्रॉइड पे अगर एक्ट करेगा, ऑब्वियसली बात है कि आपका जो ये बीच में एक तरह से फलक्रम का काम करेगा, तो बेचारा जो A है वो कोई लोड ले ही नहीं पाएगा. All the load will be coming at the point B. As simple as that. Clear? तो दिस इज व्हाट अ वेरी गुड क्वेश्चन इज. क्लियर? आई होप आपको समझ में आया. बहुत ही प्यारा क्वेश्चन था ये. चलिए आगे बढ़ते हैं. लेट अस प्रोसीड फर्दर. नेक्स्ट क्वेश्चन इज क्वेश्चन नंबर 2. नाउ यू ट्राई टू सॉल्व दिस क्वेश्चन स्टूडेंट्स. आई एम गिविंग यू 5 मिनट्स ऑफ टाइम टू सॉल्व दिस क्वेश्चन. आप इसको आराम से सॉल्व कीजिए आप इसको सॉल्व स्टूडेंट्स. टू ट्राई टू सॉल्व दिस क्वेश्चन. एवरीवन ट्राई टू सॉल्व दिस क्वेश्चन स्टूडेंट्स. एवरीवन. द रेशियो ऑफ द रिएक्शन एट A and RA and RB of the simply supported beam shown in the figure is. So you have to find the ratio of RA and RB. Now students, what will the ratio of RA and RB? You tell me that. It is a very simple question students. Try कीजिए. Try कीजिए students, try कीजिए. I am giving you so much time to solve this question. आया किसी का आंसर स्टूडेंट्स? आया किसी का आंसर? एनीवन? ट्राई कीजिए स्टूडेंट, ट्राई कीजिए. बहुत इजी क्वेश्चन है. इट इज अ वेरी इजी क्वेश्चन. ट्राई इट एटलीस्ट. देखिए स्टूडेंट, बड़ा इजी क्वेश्चन है. देखिए जरा. अब नाउ द सेम थिंग इज देयर, राइट? सो आर ए, different marker here, so this is, yes, so RA plus RB is equal to how much? The upper loading, right? That is 5 plus 3 is 8, 8 plus 2 into 2, that is equal to 12 tons. RA plus RB is equal to 12 tons. Clear? Now taking the moment about the point B is equal to 0. If you take the moment about the point B equal to 0, RA into 8 minus 5 into 6 minus 2 into 2 into 3 minus 3 into 2, that is equal to 0. So RA is going to be 3 into 2 is 6, 3 into 2 is 6 into 2 is 12, 12 plus 6 is 18, 18 plus 30 is 48, 48 divided by 8, that is equal to 6 kilonewton. So RA is equal to 6 kilonewton. If RA is equal to 6, RB will also be equal to 6. RB will also be equal to 12 minus 6, that is equal to 6 kilonewton. So not kilonewton, tons, sorry, tons, not kilonewton, tons. But whatever it is, because we have to find the ratio, ultimately the units will get cancelled out. If it is so, students, you will find that RA upon RB is going to be 6 by 6 and it is equal to 1. So this is going to be the ratio of the RA and RB. So RA and RB is going to be 1 is the correct answer of this question. I hope that you have got it. But an easy question, it was not a difficult question at all. I hope that you have got it, right? The next question on your screen is question number 3. It is an MSQ question, by the way, right? It is an MSQ question. Question number 3. Two simply supported beams are loaded in two different ways as shown in the figure. Due to certain loading intensity of W kilonewton per meter on the beam A, okay, this is my beam A, okay, the maximum bending moment is 10 kilonewton meter. Which of the following is or are true? Now give the answer of this question, students. Very easy question. It is not a difficult question. Very easy question. Try कीजिए आप इसका आंसर देने का. Try कीजिए. Everyone. ये आपका beam number 1 है और beam number 2 है आपका, right? These are two simply supported beams are loaded in two different ways as shown in the figure. Due to certain loading intensity of W kilonewton per meter on beam A, the maximum bending moment is 10 kilonewton meter. So first of all, you have to find that what is the maximum bending moment in case of a triangular loading, and that is equal to, you have to find the maximum bending moment at the center of the beam, and you should put it equal to 10, and you will be getting the value of this W. As simple as that. Clear? बताइए स्टूडेंट्स, बताइए, ट्राई कीजिए आप लोग, ट्राई कीजिए। देखिए स्टूडेंट्स, मैं आपको हिंट देता हूं, हाउ कैन यू सॉल्व इट। So the two simply supported, first of all, you have to find the bending moment at the center, right? Two simply supported beams are loaded in two different ways as shown in the figure. Due to certain loading intensity W kN per meter on the beam A, the maximum bending moment is 10 kilonewtons. First of all, you have to find the maximum bending moment. So RA is going to be how much? RA is going to be equal to RB is going to be equal to half into base into height, and base is equal to 1 divided by 2. And this is also divided by 2. कहाँ गया? Yes. So this is equal to divided by 2. So RA is going to be equal to RB is going to be equal to W into L by 4 or W by 4, because L is equal to 1 meter, so it is going to be W by 4, this much. Clear? Now students, you have to find the bending moment at the center. So bending moment at the center is going to be W by 4 into 1 by 2 minus half into base into height and into it is 1 by 3 of 1 by 2, 1 by 3 of 1 by 2. So this is the bending moment at the center, and this is given as equal to how much? This is given as equal to 10 kilonewton meter. It is equal to 10. So from here you can easily find out the value of this W here. Clear? Now once you have got the value of this W, so that is what the loading is acting. So you can say that, okay, whether this is which one is the correct answer. Clear? What if you have got the value of W, it becomes very simple for you to calculate the value of the maximum bending moment and the minimum bending moment also. It becomes very simple. Clear? So I have given you a very big hint, students, that how can you solve this type of question, how can you solve this question. Clear? मैंने आपको हिंट दिया, मैं इसको पूरा सॉल्व नहीं करूंगा, it will take a lot of time, but I have given you a hint. So this question is an assignment for you. Let me write it here also. This question is an assignment for you. I have given you a hint. This will be discussing in the next lecture. Clear? This question is an assignment for you. Also students, now regarding this question, for the beam, the loading and loading of the steel rolled steel shape as shown in the figure, the section modulus Z is equal to this, then the magnitude of the bending moment is this. Now what is the meaning of section modulus? Section modulus is nothing but it is just equal to I by Y. I by Y. You just try this question at least once at your home. If you are able to solve it, well and good. If you are not able to solve it, doesn't matter. I will be solving this question when I will be teaching you about the bending stresses. There also will be solving this question. Clear? So this question is also an assignment for you. This question is also an assignment for you. Assignment. Clear? Next question is MSQ. The bending moment in a cantilever beam of span of length 15 centimeter is shown in the figure. Is shown as a function of x as this much. X is in centimeter from the free end and m is in Newton meter. Which of the following statement is true? The location of the maximum bending moment. So you already know that how do you find the location of the maximum bending moment. Clear? How do we find the location of the maximum bending moment and minimum bending moment. Clear? So for the maximum bending moment, the slope of the bending moment should be equal to 0. Because in this case also, let us say you have the maximum bending moment. So the slope of this particular thing here is equal to 0. So you will say that it is equal to dm by dx is equal to 0. And you will be getting the value of this x here. Once you have got the value of this x, you can say that, okay, this is the location at which you have the maximum bending moment. So that is what, very simple. I have given you a hint. This question is also an assignment for you. This is also an assignment for you. Clear? Next is, it is also an MSQ question. A horizontal beam AD 10 meter long carries a UDL of this much and a concentrated load of this much. Okay, this much. This is also a very simple question, students. You just have to apply the basic concepts of bending moment and shear force diagram. You will get the answer of this question. This question is also an assignment for you. Assignment for you. Next is a propped cantilever, okay, carrying a UDL as shown in the figure. The vertical reaction at support X. This can be solved by superposition method. Now, what is the superposition? I will be telling you later on. Till now, don't have to worry about it. If you want to solve it, you can solve it with the help of The assignment, it is also an assignment question for you. But if you are not able to solve it, doesn't matter. I'll be solving in the next lecture. Don't have to worry at all. Next question is the bending moment distribution. This can also be solved with the help of this dm by dx. It gives you the shear force, as simple as that. Clear? You put the value of x equal to 3 here, you will be getting the answer. This is also an assignment question for you. Clear? Next question is the bending moment at the point O in the beam. Now this is a good question. In this, the spring is given to you. First of all, you have to find the spring constant K, and from the spring constant K you can find the vertical reaction force at the point B, at the spring point B, and there you can find the value. So this is also an assignment question for you. Because we are meeting day after tomorrow, so you have tomorrow's day left completely with you. You try to solve all these questions. The next question is the magnitude of the reaction force at the joints. This is also a very easy question, student. This can also be done with the help of the superposition principle. But since internal hinge is given to you at the point B, you have an internal hinge. There is no need to go for the superposition method. You can directly solve this question with the help of the equilibrium equation, summation of fx0, summation of fy0, all these things. So this question is also an assignment for you. These assignment questions we'll be discussing in the next lecture. I hope that you will be solving these questions. Clear? So these are some of the assignment questions for you, students. So try to solve these questions. Till then, thank you everyone. Have a nice day. Bye bye. Take care. Thanks for watching. And in the next lecture, we'll be discussing about the various cases of the SFD and BMD, and we'll be solving some numericals on the SFD and BMD, some difficult questions on the SFD and BMD. Till then, students. So thank you everyone. Have a nice day. Bye bye. Take care. Bye.